June 6, 1944, somewhere near Rouen, France. The metallic glint of a damaged P-51 Mustang descended through broken cloud cover, its Packard Merlin engine trailing a thin ribbon of smoke. Lieutenant Thomas Fraser of the 334th Fighter Squadron, 4th Fighter Group, had lost his bearings during the chaos above the Normandy beaches. His fighter, bearing the squadron code QPG and nicknamed Jerry, struck the French countryside hard. Fraser survived the crash landing and would spend the remainder of the war as a prisoner of war. But his aircraft, serial number 43-24825, a P-51B-15-NA model, was about to embark on a journey that would profoundly shake the assumptions held by some of the Luftwaffe's most experienced test pilots. The Mustang lay relatively intact in that French field, soon to be recovered by German salvage teams who had perfected the systematic art of retrieving crashed Allied aircraft across occupied Europe. Within weeks, this particular machine would be transported to Rechlin, the Luftwaffe's primary testing facility located approximately 100 kilometers northwest of Berlin in Mecklenburg, where it would undergo repairs using components cannibalized from other less repairable wrecks scattered across German-controlled territory. The aircraft would emerge wearing German markings, its fuselage bearing the Luftwaffe code T9 plus HK, its tail and undersides painted in bright RLM 04 yellow for easy identification by German pilots, who might otherwise mistake it for an enemy aircraft during flight operations. The propeller spinner received yellow paint, and a red band adorned the nose of the engine cowling, following standard Luftwaffe identification procedures for captured aircraft. This Mustang was destined for service with one of the Luftwaffe's most unusual and specialized units, the Wunderzirkus Rosarius, where it would force German fighter pilots to confront an uncomfortable reality about American engineering prowess, industrial capabilities, and their own increasingly untenable tactical situation in the deteriorating air war over Europe. The story of how captured enemy aircraft became instruments of revelation for the Luftwaffe begins not with Fraser's forced landing on the day of the Allied invasion, but with the escalating air war over Europe, and the desperate need for accurate, systematic intelligence about Allied aircraft capabilities that went beyond fragmentary combat reports. By mid-1943, the Luftwaffe faced a strategic crisis that threatened to overwhelm German air defences, despite the considerable skill and courage of individual pilots and the ongoing development of advanced aircraft designs. American bomber formations were penetrating deeper into the Reich with each passing month, protected by fighters whose true capabilities remained partially mysterious to German commanders who had to make tactical and strategic decisions based on incomplete information. Intelligence reports from combat pilots provided fragmentary accounts of enemy aircraft performance, but these reports often conflicted with one another and reflected the chaos and confusion of aerial combat rather than systematic, controlled analysis under consistent conditions. Hauptmann Theodor Rosarius, an experienced Luftwaffe officer, understood that German fighter units needed more than scattered combat reports and second-hand accounts to counter the Allied threat effectively. They required hands-on experience with captured enemy aircraft, structured opportunities to fly these machines under controlled conditions, and systematic evaluation to discover their strengths and vulnerabilities through direct observation and testing. The concept was not new. Both the Allies and Germans had tested captured aircraft throughout the war, but Rosarius would organize and systematize the approach in ways that maximized its tactical value. In 1943, following orders from General der Jagdflieger Adolf Galland, Rosarius formed what would become known as the Wunderzirkus Rosarius, officially designated as the Second Staffel of the Versuchsverband Oberkommando der Luftwaffe, the Trials and Research Unit of the Luftwaffe High Command. This specialized unit received all repairable captured Allied aircraft that German salvage teams recovered from crash sites across occupied Europe, from France to Italy to the Eastern Front. The unit's mission extended well beyond simple static testing at secure facilities behind the lines. Rosarius organized traveling demonstrations where captured aircraft would visit operational Luftwaffe fighter bases across Germany and occupied territories, allowing frontline pilots to examine these machines up close, observe them perform aerial demonstrations, and in carefully selected cases, fly mock combat missions against them. The program addressed a fundamental problem in pilot training that had become increasingly critical as the war progressed and pilot attrition increased. German fighter pilots trained primarily against their own aircraft, learning tactics optimized for fighting opponents who flew and fought like Germans, using similar aircraft with comparable performance characteristics, and employing tactical doctrines that emerged from shared training and doctrinal foundations. This created a dangerous blind spot when engaging Allied pilots whose aircraft possessed markedly different performance characteristics, especially regarding range, high-altitude capability, and sustained speed, and whose training emphasized different tactical approaches that leveraged these specific advantages. The recovery operation for Allied aircraft had become highly systematized by 1944, with specialized German salvage units operating across occupied territories under the direction of Bergbataillon, or salvage battalions. These teams worked with remarkable efficiency to secure crash sites, assess damage, and transport repairable aircraft to centralized testing and repair facilities before advancing Allied forces could recapture the wrecks. The organizational structure reflected German military thoroughness even as resources grew scarcer. The scale of Allied air operations over Europe made captures inevitable through sheer statistical probability. With thousands of sorties flown monthly by American and British forces, mechanical failures, battle damage, navigation errors, fuel exhaustion, and weather-related incidents resulted in numerous forced landings on German-controlled territory. Not all of these aircraft were destroyed on impact or rendered irreparable by crash damage. Some pilots, recognizing their situation was hopeless, executed controlled crash landings that left their machines largely intact, sometimes even with minimal structural damage that could be repaired with available resources and components. Fraser's P-51B-15NA fell into this category of repairable captures. The aircraft had sustained damage during the intense fighter sweeps supporting D-Day operations, forcing an emergency landing in territory that remained under German control despite the invasion. German recovery teams reached the site within hours, following established procedures for evaluating crash sites. They examined the Mustang carefully, assessed the extent of damage, and determined that despite battle damage and crash impact, the airframe remained sufficiently intact for repair and restoration to flight-worthy condition. The aircraft was carefully loaded onto a specialized transport and sent to Rechlin, where experienced technicians and engineers worked systematically to restore it to flying condition. Rechlin Testing Center, formerly known as Erprobungsstelle Rechlin and located near Lake Müritz, served as the Luftwaffe's primary facility for evaluating new German aircraft designs and conducting detailed testing of captured enemy types. The facility, which had been officially designated the Luftwaffe's Central Testing Facility on February 26, 1936, included extensive workshops equipped with specialized tools, comprehensive test ranges for various evaluation protocols, and runways specifically configured for evaluation flights under controlled conditions. Technicians at Rechlin possessed considerable skill in reverse engineering and repairing Allied aircraft, despite lacking original technical manuals, factory specifications, and genuine spare parts manufactured to original tolerances. The repair process for Fraser's Mustang required substantial ingenuity and resourcefulness that spoke to both German technical competence and the increasing challenges of working with limited resources. Technicians cannibalized components from other crashed P-51s recovered across Europe, building an inventory of parts that could be matched and fitted to create one flight-worthy aircraft from multiple damaged machines. The Packard 5 1650-3 Merlin engine, a license-built version of the Rolls-Royce Merlin 63 with a two-stage, two-speed supercharger that produced 1,490 horsepower at 13,750 feet, using 61 inches of mercury boost pressure, underwent detailed inspection and necessary repairs using replacement parts obtained from multiple sources. This engine represented a significant technological achievement, delivering substantially more power at altitude than single-stage supercharged engines through its sophisticated intercooled two-stage supercharger system. The aircraft's 4.50 caliber Browning M2 machine guns, mounted 2 per wing in the P-51B configuration, were removed and replaced with ballast weights to maintain proper weight distribution and center of gravity, as German regulations strictly prohibited arming captured aircraft used for testing and demonstration purposes. This restriction reflected both safety considerations and concerns about captured aircraft potentially being used against German forces if they fell back into Allied hands through mishap or defection. Control surfaces were thoroughly examined for structural integrity and proper operation. Hydraulic systems underwent pressure testing and inspection for leaks. Fuel tanks were carefully inspected for damage, cracks, and potential leak points that could cause catastrophic failure during flight operations. The Razorback canopy design that characterized the P-51B was carefully preserved and repaired, though German pilots would later note how the framed canopy restricted rearward visibility compared to the bubble canopy introduced on the later P-51D variant. After weeks of meticulous work by skilled technicians working with limited resources and improvised solutions, the Mustang was declared ready for initial test flights. German test pilots approached their first encounters with captured American fighters with professional curiosity mixed with considerable skepticism born from years of Luftwaffe propaganda. Official information had consistently portrayed American aircraft as crude, mass-produced machines that prioritized quantity over quality, emphasizing manufacturing ease and simplicity rather than sophisticated engineering and refined performance. The prevailing view among many German pilots, reinforced by official communications, held that American engineering focused on producing adequate numbers of acceptable aircraft, rather than pursuing the engineering excellence and performance optimization that characterized the best German designs. These comfortable assumptions began dissolving rapidly the moment experienced German test pilots climbed into the Mustang's cockpit and experienced firsthand what American designers and engineers had actually achieved through careful design, sophisticated engineering, and meticulous attention to operational requirements. The cockpit layout of the P-51B immediately impressed German pilots familiar with the cramped confines of Messerschmitt B F-109 cockpits, and even the more spacious accommodations of Focke-Wulf FW-19Os. The Mustang cockpit demonstrated thoughtful ergonomic design, with controls logically arranged and positioned within easy reach, reducing pilot workload and allowing concentration on tactical situations rather than struggling with aircraft systems. Instruments were clearly marked with easily readable gauges and sensibly grouped by function, following human factors principles that prioritized pilot effectiveness. The seat provided noticeably better comfort than German fighters, an important consideration during multi-hour missions where pilot fatigue could significantly impact performance and decision-making. Visibility, even in the earlier Razorback configuration with its framed canopy, exceeded what Bf-109 pilots experienced with their heavily framed canopies, restricted sightlines, and particularly poor rearward visibility that left German pilots vulnerable to attacks from behind. But the true revelation came when German test pilots advanced the throttle and felt the Packard 5 16503 Merlin engine respond with smooth, progressive power delivery. The power built steadily and predictably as the Mustang accelerated down Rechlin's runway, the four-bladed Hamilton standard propeller biting efficiently into the air. The takeoff roll was noticeably shorter than expected for an aircraft of the P-51's weight and size, clear testimony to the engine's substantial power output and the airframe's efficient aerodynamic design that minimized drag throughout the speed range. Once airborne, the Mustang demonstrated handling characteristics that fundamentally challenged everything German pilots thought they understood about American aircraft design philosophy and engineering capabilities. The flight controls were beautifully harmonized, with aileron, elevator, and rudder forces perfectly balanced across the entire speed range, from approach speeds to maximum velocity. Control forces increased predictably with speed, providing good feedback without becoming excessively heavy, and decreased smoothly at lower speeds without becoming overly sensitive or twitchy. The Mustang responded crisply and predictably to control inputs without displaying the oversensitivity or nervous handling characteristics that plagued some fighters. Roll rate exceeded that of the BF-109 significantly, and approached the exceptional roll performance of the FW-190, allowing rapid changes in flight direction that were critical for both offensive and defensive maneuvering in combat. The aircraft could be thrown aggressively into various maneuvers without displaying any troubling tendency toward departure from controlled flight, spin entry, or other dangerous characteristics that could prove fatal in combat situations. German test pilots systematically evaluated the Mustang's performance envelope through carefully planned test flights, pushing the aircraft through standardized maneuvers specifically designed to reveal its strengths, limitations, and any hidden dangerous characteristics. Climb performance impressed them considerably and generated significant concern about tactical implications. The P-51B could maintain excellent climb rates to altitudes well exceeding 30,000 feet, where the two-stage supercharged Merlin engine continued producing substantial power, even as the progressively thinner air at altitude severely degraded performance in German fighters equipped with single-stage superchargers. High-altitude performance particularly concerned German pilots and tactical planners, because American bomber formations typically operated between 25,000 and 30,000 feet, where the air was thin and cold, but defensive fire from bombers remained effective against fighters that had to slow down to attack. German fighters equipped with single-stage superchargers struggled increasingly to intercept effectively at these altitudes, their engines gasping for sufficient air, while the Mustang's sophisticated two-stage Merlin continued delivering robust, reliable power. The revelation proved sobering to pilots and commanders who understood the implications. The Mustang could not only escort bombers to these altitudes, but could fight there effectively, maintaining speed advantage and maneuverability, while German interceptors labored with reduced power, slower speeds, and degraded handling as their engines fought against the thin atmosphere. Speed trials conducted under controlled conditions at various altitudes confirmed the Mustang's clear superiority in this critical performance category. The P-51B could achieve approximately 440 miles per hour at optimal altitude with the engine running at military power settings, significantly faster than the Messerschmitt Bf-109G's approximately 386 miles per hour, and the Focke-Wulf FW-190A's approximately 408 miles per hour when measured under comparable conditions. This substantial speed advantage proved tactically decisive in combat, because it fundamentally allowed Mustang pilots to dictate engagement terms according to their advantage. American pilots could choose when to engage, pursuing fleeing German fighters when the tactical situation favored attack. Equally important, they could choose to disengage from unfavorable encounters, accelerating away from German fighters that lacked sufficient speed to pursue or force continued combat. German pilots discovered they could not force combat on a Mustang whose pilot recognized an unfavorable situation and chose to avoid engagement, fundamentally undermining German tactical flexibility. The wing design of the P-51, based on NACA laminar flow airfoil sections, gave the Mustang its distinctive appearance and delivered exceptional aerodynamic efficiency, though German engineers noted that achieving true laminar flow in operational conditions remained elusive due to manufacturing tolerances, surface imperfections, rivets, paint, and operational wear. Nonetheless, the P-51's wing generated substantial lift with minimal drag compared to conventional airfoils, significantly contributing to the aircraft's remarkable range and fuel efficiency. This wing design maintained its effectiveness across a remarkably broad speed range, from relatively low-speed handling during landing approaches through high-speed performance during combat maneuvering, providing consistent, predictable handling characteristics that reduced pilot workload and enhanced combat effectiveness. Dive performance revealed yet another area where the Mustang demonstrated clear superiority over German fighters. The aircraft could dive at very high speeds without encountering the severe control stiffening and reduced control effectiveness that plagued many fighters when approaching or exceeding their maximum design speeds. Pilots could pull out of steep, high-speed dives without requiring excessive physical effort or fighting against locked controls, and the airframe remained stable throughout the maneuver without tendency toward flutter, buffeting, or structural failure. German test pilots noted this capability with particular interest and concern, because diving attacks represented a primary German tactical doctrine for engaging bomber formations and escorting fighters, attacking from altitude to build speed and energy before pulling back up. The Mustang's ability to follow German fighters through high-speed dives and maintain full control authority throughout the maneuver eliminated a key German tactical advantage. Turn performance presented a more complex and nuanced picture that required careful analysis. The Mustang could not match the sustained turn rate of the Bf-109 in level flight at moderate speeds, particularly as the Bf-109 benefited from leading-edge slats that automatically deployed during high angle of attack maneuvering and delayed wing stall during tight turns. In sustained, slow-speed turning fights at medium altitudes, the lighter and more compact Bf-109 held a measurable advantage in turn radius and turn rate. However, German pilots discovered through systematic testing and mock combat that the Mustang's clear superiority in speed and climb rate allowed skilled pilots to avoid sustained turning engagements entirely and instead fight using energy tactics. The Mustang excelled at converting speed to altitude and altitude back to speed efficiently, enabling pilots to maintain energy state throughout combat maneuvering. This capability allowed Mustang pilots to engage when advantageous and disengage when threatened, forcing combat on their terms rather than accepting the enemy's preferred combat geometry. The Mustang's structural strength and robust construction impressed German engineers who examined the airframe in systematic detail at both Rechlin and at Göttingen, where more detailed technical evaluations occurred. The aircraft was substantially built with significant safety margins engineered into critical structural components throughout the airframe. This robust construction philosophy contrasted markedly with German design approaches that often pushed structural limits to absolute minimums in pursuit of weight reduction and maximum performance. The P-51 could sustain significant battle damage that would have destroyed lighter German aircraft and still successfully return to base, a capability that directly translated into pilot survival rates and aircraft availability for subsequent missions. American engineering philosophy clearly emphasized survivability and maintainability, accepting somewhat higher empty weight in exchange for durability that kept aircraft and pilots in combat longer. Range capabilities astounded German pilots accustomed to the severely limited endurance of their own fighters, which rarely exceeded 90 minutes of total flight time, including combat. The P-51B carried substantially more internal fuel than the Bf-109 or FW-190, and the aerodynamically efficient wing design translated this fuel capacity into truly extraordinary range that seemed almost incredible to German pilots. With external drop tanks attached under the wings, the Mustang could fly missions exceeding 8 hours duration, covering operational distances that seemed nearly impossible to German pilots, whose combat radius barely exceeded 200 miles under optimal conditions. This massive range advantage fundamentally transformed bomber escort operations in ways that proved strategically decisive. Early in the war, German fighters could simply wait until shorter-range Allied escorts reached their fuel limits and turned back toward their bases, then attack unprotected bombers during the most dangerous portions of their missions deep in German territory. The Mustang completely eliminated this tactical window. American escorts could now accompany bombers throughout entire missions deep into Germany and back to England, preventing German fighters from ever finding truly vulnerable targets. The strategic implications were profound and deeply troubling to Luftwaffe commanders, who understood that German fighters now had to fight their way through escorts to reach bombers, dramatically increasing the risk German pilots faced on every interception sortie. German pilots who flew captured Mustangs in both test flights and mock combat consistently reported being profoundly impressed by the aircraft's harmonized handling characteristics and overall ease of operation. The flight controls required neither excessive physical strength nor excessively delicate touch, striking an ideal balance that allowed pilots to fly aggressively and precisely without fear of over-controlling the aircraft or inadvertently losing control during violent maneuvering. This forgiving ease of handling meant that average pilots could extract good performance from the Mustang under most conditions, while exceptional pilots could achieve remarkable results by fully exploiting the aircraft's capabilities. Maintenance accessibility surprised German ground crews familiar with the sometimes extraordinarily difficult servicing requirements of Bf-109s and FW-190s, particularly when working under field conditions with limited equipment. The Mustang's engine cowling opened in multiple sections that provided excellent access to the Merlin engine and its accessories, fuel system, hydraulic components, and electrical systems. Panels throughout the airframe could be quickly removed to reach internal systems for inspection, adjustment, or repair. The overall design clearly reflected American emphasis on rapid maintenance turnaround and high operational availability, recognizing that aircraft sitting on the ground awaiting repairs contributed nothing to combat effectiveness, regardless of their theoretical performance capabilities. The Wunderzirkus Rosarius took the captured and repaired Mustang-coded T9 plus HK on an extensive tour to operational Luftwaffe fighter bases across Germany during late 1944, visiting numerous locations where frontline fighter units were based. At each stop, the unit would establish temporary operations and set up comprehensive demonstrations, showing German pilots exactly what Allied aircraft could do in flight and teaching them specific tactics designed to counter Allied strengths while identifying and exploiting whatever weaknesses could be found. The demonstrations typically began with captured aircraft taxiing past assembled German pilots and ground personnel, creating surreal scenes as enemy aircraft bearing German markings and bright yellow identification paint moved among German fighters. Seeing these aircraft up close had substantial psychological impact, making the enemy tangible and real rather than abstract. Then came flight demonstrations where experienced German test pilots would fly the captured aircraft through carefully choreographed aerobatic routines and tactical maneuvers, demonstrating specific performance capabilities in ways that were far more effective than written reports or verbal briefings could ever be. For the Mustang demonstrations, test pilots would perform high-speed passes at low altitude to dramatically show the aircraft's significant speed advantage over German types. They would execute climbing maneuvers to altitudes exceeding 30,000 feet to display the remarkable climb performance and high-altitude capability enabled by the two-stage supercharged engine. They would demonstrate the P-51's excellent roll rate through a series of crisp aileron rolls that showed how quickly the aircraft could change direction. Mock dogfights against German fighters would illustrate both the Mustang's strengths and the limited circumstances under which German fighters retained advantages. After the flying display concluded, pilots and ground personnel could approach the aircraft on the ground, examine it closely, inspect the cockpit layout and instrument panel, and ask detailed questions of the test pilots who had extensive experience flying the captured machine. These hands-on educational sessions proved invaluable for demystifying enemy aircraft and providing concrete, tangible understanding of what German pilots faced in actual combat operations. The most valuable and impactful component of these base visits involved mock combat sessions, where captured Allied fighters would engage German fighters in carefully controlled simulated combat under observation. Selected experienced German pilots would fly their own operational aircraft against the captured types, experiencing firsthand how Allied fighters handled in dynamic combat situations and learning what worked and what proved ineffective against specific Allied aircraft. One such demonstration took place at an airfield hosting Jagdgeschwader 1 during late 1944, as Allied bomber operations intensified and German losses mounted. The base commander had arranged for several of his most experienced pilots to fly mock engagements against the captured Mustang to gain practical knowledge they could pass on to squadron mates. The German test pilot flying the P-51 demonstrated tactics that American pilots typically employed in actual combat, using the Mustang's clear advantages in speed and climb performance to maintain energy throughout the engagement while avoiding situations where the Mustang's lesser turn performance became a significant disadvantage. German pilots flying Messerschmitt Bf-109Gs and Focke-Wulf FW-190 as attempted to engage the Mustang using standard Luftwaffe tactics that had proven effective against earlier Allied fighters. They quickly discovered the extreme difficulty of successfully engaging a Mustang whose pilot understood and properly utilized energy management techniques and the aircraft's performance advantages. When German pilots pursued aggressively, the Mustang would simply accelerate away, opening distance faster than the pursuing German fighters could close it. When German pilots attempted to climb to gain an advantageous position above the Mustang for a diving attack, the P-51 outclimbed them, reaching superior altitude first and reversing the tactical situation. When German pilots tried to force a sustained turning fight where the Bf-109's superior turn performance should have provided advantage, the Mustang pilot would refuse the engagement by extending away using superior speed, then reverse back into the engagement with renewed energy advantage when conditions favoured the attack. The mock combat sessions proved sobering for German pilots who had believed or hoped that their aircraft and established tactics remained reasonably competitive with Allied fighters, despite the deteriorating strategic situation. Directly observing and experiencing the Mustang's performance capabilities in dynamic combat maneuvering demonstrated clearly that American pilots flying P-51s possessed significant and fundamental tactical advantages, particularly at the high altitudes where bomber escort combat typically occurred. This pattern of revelation and gradually dawning realization repeated itself across numerous Luftwaffe bases where the Wanderzirkus Rosarius conducted demonstrations throughout late 1944 and into 1945. German pilots received official assurances about the continuing superiority, or at least competitive parity of their aircraft during pre-demonstration briefings, then experienced actual combat and flight demonstrations that directly contradicted those optimistic assessments. The captured aircraft demonstrations provided concrete, undeniable evidence that German fighters faced formidable opponents whose capabilities significantly exceeded what propaganda and official communications suggested. Walter Dahl, who commanded fighter units during 1944, later wrote about Wanderzirkus Rosarius' visits to his bases in his memoir, though historians note his accounts must be treated cautiously due to documented reliability issues throughout his writing. He described how captured American fighters would arrive, along with captured heavy bombers, creating unusual and somewhat surreal scenes where enemy aircraft parked peacefully alongside German machines while pilots examined them closely. Formation leaders received opportunities to fly captured aircraft in controlled mock combat, allowing them to understand Allied aircraft characteristics through direct personal experience, rather than relying solely on second-hand reports and official briefings. Dahl emphasized the substantial value of this training, noting that familiarity with enemy aircraft capabilities represented a factor not to be underestimated in aerial combat, where split-second decisions often determined survival. Following these demonstration sessions, flight leaders would conduct detailed training lectures with their squadron members, passing along specific recommendations and tactical insights based on their personal observations and direct experience flying captured Allied aircraft. This systematic knowledge transfer helped prepare German pilots for combat encounters with more realistic understanding of both Allied strengths and the increasingly limited circumstances under which German fighters retained exploitable advantages. The program achieved decidedly mixed results by late 1944 as Germany's strategic situation deteriorated across all fronts. While the demonstrations unquestionably provided valuable tactical intelligence and improved German pilot understanding of Allied aircraft capabilities, this knowledge could not overcome the fundamental and growing disadvantages German forces faced. The Luftwaffe suffered from chronic and worsening fuel shortages that severely limited flight training hours for new pilots, resulting in inadequately prepared pilots being sent into combat with minimal experience. Experienced pilots who understood through hard-won combat experience how to fight effectively against aircraft like the P-51 were increasingly rare, lost to relentless attrition during the brutal air combat of 1944 that saw German fighter pilot losses reach unsustainable levels. Aircraft production, while remaining surprisingly high despite intensive Allied strategic bombing of German industry, could not replace losses quickly enough to maintain force strength. Most critically, the training revelations from captured aircraft often served primarily to demoralize rather than inspire, as pilots realized the full extent of their disadvantages. German pilots recognized with growing clarity that they flew inferior aircraft, or at minimum aircraft inferior in the most critical performance categories for the missions they were assigned. The P-51's speed advantage, extraordinary range, and superior high-altitude performance could not be matched by any available German fighters in operational service. The technical intelligence gathered from captured Mustangs extended well beyond simple flight testing and combat evaluation. German engineers at both Rechlin and Göttingen systematically disassembled P-51 components to understand American manufacturing techniques, material selections, and detailed design approaches. They examined the wing structure and airfoil sections in meticulous detail, studying the construction methods and attempting to understand precisely how American designers had achieved such aerodynamically efficient performance. They analysed the Packard Faye 1650-3 Merlin engine with great interest, noting its sophisticated two-stage supercharger system with intercooler that enabled such impressive high-altitude performance. The fuel system received careful attention as engineers attempted to understand how American designers had achieved such remarkable range. The hydraulic systems were evaluated for their reliability and relative ease of maintenance compared to German systems. German engineers noted repeatedly the consistently high quality of materials used throughout the aircraft. American access to strategic materials like high-grade aluminum alloys, specialized steels, and reliable rubber compounds allowed designers to create structures that effectively combined strength with acceptable weight while maintaining production efficiency. Germany faced increasingly severe material shortages by 1944, forcing the use of substitute materials that often proved inferior in strength, durability, or manufacturing characteristics. The investigation of captured Mustangs revealed sophisticated manufacturing techniques that enabled true mass production without significantly compromising quality standards. American factories produced P-51s using highly developed assembly line methods that maintained remarkably tight tolerances and consistent quality across thousands of individual aircraft. German production had become increasingly reliant on dispersed manufacturing in smaller facilities scattered across the country to avoid concentrated bombing, sometimes using inadequately trained forced labour, resulting in inconsistent quality, reduced production efficiency, and increasing maintenance problems with operational aircraft. The captured Mustang, designated T9+HK, served with the Wanderzirkus Rosarius until December 10, 1944, when the aircraft and its pilot Oberleutnant Leo Potjans were lost. Historical records do not definitively specify whether the aircraft crashed during a demonstration flight, was destroyed on the ground during an Allied air raid against the airfield where it was stationed, or fell victim to other wartime circumstances. By that point in its second operational life, the aircraft had travelled extensively across Germany, visiting numerous Luftwaffe bases and providing direct, hands-on education to hundreds of German pilots who gained invaluable first-hand knowledge of American aircraft capabilities. Other captured Mustangs served similar evaluation and demonstration roles for the Luftwaffe. German records and post-war research indicate that at least 2 P-51s definitely operated with the Wanderzirkus Rosarius at various times during 1944 and early 1945, bearing the Luftwaffe codes T9 plus CK and T9 plus HK. Historical sources sometimes incorrectly list T9 plus FK and T9 plus PK as additional P-51S operated by the unit, but careful research reveals that T9 plus FK was actually a captured P-47D Thunderbolt, not a Mustang, while T9 plus PK was a captured Soviet Lavochkin La-5FN fighter. The T9 designation code was not officially assigned to any existing Luftwaffe operational formation in German organizational records, strongly suggesting it represented an ad hoc code used specifically for Wanderzirkus Rosarius captured aircraft operations, rather than following standard Luftwaffe organizational structure. Documentation indicates that one captured P-51B was used at Neuruppin airfield, located approximately 60 kilometers northwest of Berlin, to train Hungarian fighter pilots on effective tactics for using their Focke-Wulf FW-190s against American Mustangs. This transfer of tactical knowledge to German allies reflected recognition that the Mustang represented a significant and growing threat requiring specialized counter-tactics that needed to be disseminated widely. The training emphasized identifying and exploiting the limited areas where German and Hungarian fighters retained advantages, such as sustained turn performance at lower speeds and altitudes, while studiously avoiding situations that played directly to the Mustang's overwhelming strengths in speed, climb rate, and high-altitude performance. The broader implications of German pilots directly experiencing and thoroughly understanding superior American fighters extended well beyond immediate tactical considerations. The Mustang represented tangible, undeniable evidence that American industrial and engineering capabilities equaled or exceeded German achievements in critical areas, contradicting years of propaganda about American industrial and technical inferiority. This uncomfortable realization challenged fundamental assumptions about relative national capabilities and contributed significantly to declining morale among German pilots, who increasingly understood they fought at a severe and growing disadvantage that no amount of skill, courage, or tactical cleverness could fully overcome. The Mustang's range capabilities particularly troubled German commanders because they clearly recognized the decisive strategic implications. The bomber war over Germany, which had seemed potentially containable when Allied escorts possessed limited range and had to turn back before reaching deep targets, became effectively unstoppable once Mustangs could provide continuous escort coverage throughout entire missions. German fighters could no longer wait for escorts to reach their fuel limits and turn back before attacking bombers. Every bombing mission now featured fighter escort throughout, dramatically increasing the risk German pilots faced when attempting intercepts and forcing them to fight through screens of superior Allied fighters to reach bomber formations. Production numbers told a devastating story about relative industrial capacity. By late 1944, American factories were producing approximately 500 P-51s monthly, and this figure would climb even higher, reaching 881 aircraft per month by January 1945 at peak production. This output exceeded more than double the combined production rate of all German single-engine fighter types, including Bf-109s, FW-190s, and newer types. Moreover, these Mustangs were equipped with reliable engines built to consistent quality standards, sophisticated and accurate instruments, and radio equipment that actually worked consistently and reliably, unlike the often unreliable and poorly manufactured equipment in late-war German fighters. American pilots flew aircraft that had been properly maintained by well-trained ground crews with adequate supplies of genuine spare parts, proper tools, and technical manuals, while German forces struggled with increasingly severe maintenance challenges created by parts shortages, substitute materials, undertrained or forced labor personnel, and dispersed maintenance facilities. The quality and thoroughness of American pilot training also became increasingly apparent through combat encounters analysed by surviving German pilots. American pilots typically arrived at operational units with 200 to 400 hours of total flight training time, including extensive instruction in advanced combat tactics, instrument flying under various weather conditions, and formation procedures. German pilot training had been dramatically and dangerously shortened by late 1944 due to severe fuel shortages and the loss of training facilities and experienced instructors. New pilots sometimes arrived at frontline units with barely 100 hours total flight time, minimal combat training, and often no instrument training whatsoever, leaving them dangerously unprepared for the reality of combat operations. These inadequately trained pilots faced veteran American pilots flying objectively superior aircraft, a combination that produced grimly predictable results reflected in German loss statistics. German loss rates among fighter pilots increased dramatically and unsustainably during 1944 and early 1945. Experienced pilots who understood through hard-won combat experience how to maximize their aircraft's remaining strengths while minimizing exposure to enemy advantages were killed or seriously wounded faster than replacement pilots could be trained, even under the compressed and inadequate training programs. New pilots with minimal training survived only a handful of missions on average before being shot down, bailing out if they were fortunate, dying if they were not. The Luftwaffe was hemorrhaging its most valuable and irreplaceable asset, skilled, experienced pilots with the knowledge and judgment necessary for survival and effectiveness, at rates that could not possibly be sustained. The Wanda Circus Rosarius demonstrations revealed these harsh realities directly to German pilots before they encountered them in actual combat, where the stakes were life and death. While this advanced preparation theoretically improved their chances of survival by providing realistic understanding of what they would face, it simultaneously made painfully clear the deteriorating situation German forces faced across all dimensions of the air war. Pilots who flew the captured Mustang or observed demonstration flights understood with uncomfortable clarity that they would confront opponents with significant and fundamental performance advantages in the specific areas that mattered most: speed, range, high-altitude capability, and overall numbers. This knowledge, while possessing some tactical value, contributed substantially to the severe psychological pressure German pilots experienced during late 1944 and early 1945, as strategic reality became impossible to ignore. Some German test pilots who extensively flew captured P-51s through multiple test flights, and mock combat engagements developed grudging professional respect for American engineering prowess and design philosophy, despite their position as enemies. They recognized through direct experience that the Mustang represented a coherent, well-integrated design that intelligently prioritized the characteristics most valuable for its intended strategic mission of long-range bomber escort. The aircraft deliberately sacrificed some characteristics like sustained turn performance that might have been optimized for pure dogfighting in favor of speed, extraordinary range, and high-altitude performance that enabled it to escort bombers deep into Germany and fight effectively throughout the mission. This represented sound engineering judgment that selected appropriate design compromises to achieve clearly defined mission objectives rather than pursuing theoretical performance maxima that didn't serve actual operational requirements. The Mustang's ease of production also impressed German engineers who understood manufacturing challenges intimately through their own experiences. The aircraft's design facilitated true mass production through modular construction that allowed parallel manufacturing, standardized components that reduced complexity and training requirements, and design features that deliberately simplified assembly operations. American factories could produce Mustangs in large numbers while maintaining consistently high quality because the fundamental design itself accommodated production requirements from the beginning rather than treating manufacturing as an afterthought. German aircraft designs often prioritized absolute performance over manufacturability, resulting in aircraft that were difficult and time-consuming to produce even under optimal conditions, much less in the deteriorating circumstances of late-war Germany. The Packard 5 1650-3 Merlin engine that powered Fraser's P-51B and other early production Mustangs represented another critical area where American capabilities exceeded German achievements. The Packard Company successfully manufactured Rolls-Royce Merlin engines under license in the United States, producing many thousands of engines with remarkably consistent quality despite the complexity of the design. The sophisticated two-stage supercharger with intercooler enabled excellent and sustained high-altitude performance that German inline engines could not match, while the engine proved reliable and relatively maintainable under field conditions. German inline engines like the Daimler-Benz DB605 suffered from increasing quality problems during 1944, as severe material shortages forced the use of substitute materials and production dispersal to avoid bombing significantly reduced quality control effectiveness. The psychological impact on German pilots, who thoroughly understood through direct experience the performance gap they faced, cannot be overstated or dismissed as mere morale problems. These men had entered the war confident in their superior training, the capabilities of their aircraft, and the effectiveness of their tactical doctrines. By late 1944, extensive combat experience and direct exposure to captured Allied aircraft through programs like the Wanderzirkus Rosarius had systematically eroded that confidence. They recognized with painful clarity that they fought opponents who possessed decisive advantages in aircraft performance, overwhelming numerical superiority, better logistics support, more thorough training, and superior intelligence. Flying combat missions under these conditions required extraordinary courage that bordered on fatalism and acceptance of likely death or severe injury. Former Luftwaffe pilot accounts and post-war interviews from this period frequently describe the hopeless feeling of watching American fighter formations appear on the horizon and knowing intellectually that those escorts could not be avoided through any tactical maneuver and could not be outrun by any German fighter in operational service. German pilots understood that engaging Mustangs at high altitude meant fighting at severe disadvantage in every performance category that mattered. Declining to engage meant allowing American bombers to strike targets unopposed, accelerating Germany's military and industrial collapse. Neither option offered acceptable outcomes from a professional military perspective, yet these were the stark choices German fighter pilots faced daily during the final year of the war as their strategic situation deteriorated beyond any possibility of reversal. The Wanderzirkus Rosarius continued operating into early 1945, conducting demonstrations with various captured aircraft as long as aviation fuel remained available in sufficient quantities, and operational airfields could be maintained against Allied ground advances from both east and west. As Allied forces advanced progressively deeper into Germany from multiple directions, the unit's ability to travel safely to operational bases to conduct demonstrations diminished steadily. Eventually, the program necessarily ceased operations as the general collapse of German military organization overtook even specialized units, like test and evaluation groups that had previously received priority for scarce resources. The ultimate fate of various captured P-51s operated by German forces remains unclear or unknown in several cases due to incomplete records and the chaos of Germany's final collapse. Some captured aircraft were certainly destroyed on the ground during Allied air raids against German airfields that intensified dramatically during 1945. Others may have been deliberately destroyed by retreating German forces to prevent their recapture by rapidly advancing Allied armies. A few possibly survived until war's end and were subsequently recovered by Allied forces advancing into Germany, though detailed records of such specific recoveries remain limited or lost. The knowledge gained from systematically testing captured Mustangs provided German pilots with valuable tactical intelligence about aircraft capabilities, optimal engagement parameters, and exploitable weaknesses, but this knowledge ultimately could not overcome the fundamental and overwhelming disadvantages the Luftwaffe faced by 1944. Understanding intellectually that the Mustang could outrun, outclimb, and dramatically outrange German fighters offered limited practical benefit when German pilots still had to engage these superior aircraft in defense of German territory under direct orders. The testing and demonstration program represented a sophisticated and systematic attempt to counter Allied advantages through tactical innovation and improved pilot knowledge. But tactics and knowledge alone could not compensate for inferior aircraft performance, severe numerical disadvantage, inadequate training due to fuel shortages, and chronic shortages of spare parts and experienced maintenance personnel. Lieutenant Thomas Fraser's P-51 B-15NA, serial number 43-24825, had an extraordinary afterlife following his forced landing on D-Day. From a crashed fighter lying in a French field, it became an instrument of revelation for German pilots, concretely demonstrating American engineering capabilities and forcing acknowledgement of Allied air superiority that no amount of propaganda could overcome. The aircraft served this important educational role until its loss in December 1944, having travelled extensively across Germany and provided hands-on experience and sobering realistic assessment to hundreds of Luftwaffe personnel. The story of captured Mustangs in German service illustrates the sophisticated and professional approach the Luftwaffe took toward understanding enemy capabilities, despite Germany's deteriorating strategic position. Rather than relying solely on fragmentary combat reports and intelligence assessments of uncertain reliability, German forces invested significant and scarce resources in recovering, repairing, and systematically flying captured Allied aircraft under controlled conditions. This systematic approach to tactical intelligence gathering represented best practices for military organizations seeking to understand opponent capabilities accurately, and it continued even as Germany's strategic situation became increasingly hopeless. The Wunderzirkus Rosarius program demonstrated that even sophisticated intelligence gathering, professional competence, and systematic analysis could not overcome fundamental material and strategic disadvantages of the magnitude Germany faced. German pilots who flew captured Mustangs gained valuable knowledge about aircraft characteristics and optimal tactics, but that hard-won knowledge primarily confirmed what many already suspected or understood. Allied aircraft possessed significant and decisive performance advantages that German industry and engineering could not match during the war's final years given resource constraints and strategic circumstances. The experience of German test pilots confronting the Mustang's capabilities and coming to terms with American engineering achievement parallels the broader German military experience during World War II's latter stages across all theatres and services. Initial confidence in German technological superiority and tactical innovation gradually gave way to recognition that Allied forces possessed decisive advantages in multiple critical areas: vast industrial capacity, access to strategic resources, enormous manpower reserves, and increasingly, sophisticated technological capabilities that matched or exceeded German achievements. The Mustang represented one particularly visible manifestation of these Allied advantages. American designers had created an aircraft that excelled at its intended strategic mission of long-range bomber escort. American industry produced it in enormous numbers with consistent quality, despite the design's complexity. American training programs prepared pilots thoroughly to extract maximum performance from the aircraft in combat. German forces could study, analyze, and appreciate these advantages through programs like the Wunderzirkus Rosarius, without being able to replicate or effectively counter them given the strategic and material constraints they faced. The technical sophistication of the P-51 challenged and ultimately demolished German assumptions about American engineering capabilities that had been carefully cultivated by propaganda. Official information had portrayed Americans as capable of producing simple, rugged equipment in vast quantities, but fundamentally incapable of sophisticated design requiring engineering excellence. The Mustang demonstrated conclusively that American engineers could create highly refined, efficient designs that matched or exceeded German capabilities in the areas that mattered strategically. The wing design represented advanced aerodynamic research successfully implemented in high-volume production. The Packard FIV 1650-3 Merlin engine demonstrated American capability to manufacture complex, high-performance engines in large quantities with consistent quality. The aircraft's systems integration reflected sophisticated engineering that successfully balanced multiple competing requirements to create a coherent, effective weapon system optimized for its intended mission. German pilots who flew the Mustang extensively could not honestly dismiss American engineering as crude or unsophisticated based on propaganda. They experienced firsthand an aircraft that handled beautifully across its flight envelope, performed superbly in the mission profile that mattered strategically, and demonstrated thoughtful, competent design throughout every system. This direct experience forced acknowledgement that American technical capabilities exceeded German preconceptions significantly, with implications extending well beyond aircraft design to broader questions about relative national capabilities in industrial production, technical education, and engineering sophistication. The strategic air campaign over Germany succeeded in large part specifically because of the P-51 Mustang's unique combination of capabilities that other aircraft could not match. Long-range bomber escort deep into Germany remained operationally infeasible until the Mustang arrived in substantial quantities during early 1944 and began flying operational missions. Previous Allied escort fighters like the Republic P-47 Thunderbolt and Lockheed P-38 Lightning, despite their considerable capabilities in other areas, possessed insufficient range to accompany heavy bombers throughout complete missions to targets deep inside Germany and back to bases in England. This critical limitation allowed German fighters to simply wait until escorts reached their fuel limits and turned back toward their bases before attacking bomber formations during the most dangerous portions of their missions. The result was unsustainable bomber losses that forced suspension of deep penetration raids. The Mustang fundamentally transformed bomber escort operations by providing continuous, effective fighter coverage throughout entire missions regardless of target distance. German fighters could no longer find extended periods when bombers flew without protective escorts. This operational reality forced German pilots to engage American fighters directly rather than simply attacking bombers, dramatically increasing the risk German pilots faced on every interception mission. Combined with growing Allied numerical superiority and declining German pilot quality due to training time reductions, Mustang escorts made bomber operations over Germany operationally sustainable for the Allies, while German attempts at interception became increasingly costly, ineffective, and ultimately futile. The Luftwaffe conducted extensive technical evaluation of captured P-51s at multiple facilities, with particularly detailed performance testing occurring at Göttingen, where German engineers created comprehensive technical reports documenting Mustang capabilities in systematic detail. These evaluations measured speed at various altitudes, climb rate throughout the altitude range, absolute ceiling, range under various configurations, and handling characteristics across the complete performance envelope under controlled test conditions. German engineers created detailed technical reports documenting all findings, comparing P-51 performance directly with German fighter types under equivalent conditions, and analyzing specific design features that contributed to observed performance. These technical reports circulated within German aviation circles, informing aircraft designers about Allied technical approaches, providing tactical planners with accurate performance data for operational planning, and giving operational commanders realistic assessments of Allied capabilities for use in tactical decision-making. The reports confirmed what combat pilots had been reporting from actual engagements. The Mustang possessed significant and decisive performance advantages in the most critical categories for the strategic mission of bomber escort. The systematic analysis highlighted the aircraft's exceptional range that enabled strategic escort missions, superior high-altitude performance enabled by the two-stage supercharged engine, high maximum speed that provided tactical flexibility, and harmonious handling characteristics that reduced pilot workload and enabled effective combat maneuvering. German engineers noted and documented specific design features that contributed to these capabilities, including the aerodynamically efficient wing design, the powerful and sophisticated supercharged engine installation, the large internal fuel capacity supplemented by external tanks, and the thoughtful systems integration throughout the aircraft. The technical intelligence gathered supported conclusions that existing German fighter designs required substantial improvements to remain competitive with current Allied types, much less future developments that would certainly incorporate lessons learned from current operations. Germany initiated several ambitious fighter development programs during 1944, specifically intended to counter Allied air superiority through advanced technology, including the Focke-Wulf FW190D with inline engine for improved high-altitude performance, the Focke-Wulf TAR 152 specialized high-altitude fighter, and various revolutionary jet and rocket-powered designs. These programs reflected clear recognition among German designers and military leaders that existing German fighters like the Bf-109G and FW-190A could not effectively counter advanced Allied aircraft like the P-51 Mustang given the performance gaps in critical areas. However, severe material shortages, production delays caused by Allied bombing and resource constraints, and the rapidly deteriorating overall war situation prevented these advanced designs from entering operational service in numbers sufficient to influence strategic outcomes or reverse Allied air superiority. The jet-powered Messerschmitt Me-262 represented Germany's most successful attempt to leapfrog Allied piston-engine fighter performance through revolutionary turbojet technology. The Me-262 possessed substantial speed and firepower advantages that made it extremely deadly against Allied bombers when flown by skilled pilots who understood how to exploit its capabilities. However, the type suffered from chronic engine reliability problems that limited operational availability, required extensive concrete runways that were vulnerable to Allied attack, consumed vast quantities of increasingly scarce aviation fuel, and arrived too late in far too small numbers to alter strategic outcomes or seriously threaten Allied air supremacy. Even the Me-262's impressive technological advantages proved strategically insufficient to overcome overwhelming Allied numerical superiority and the Luftwaffe's collapsing infrastructure, fuel supplies, and pilot training programs. The final year of World War II in Europe witnessed the Luftwaffe's systematic dissolution as an effective fighting force capable of meaningful resistance. Catastrophic pilot losses, severe and worsening fuel shortages, production difficulties caused by Allied bombing, and overwhelming Allied numerical superiority combined to render German air defense increasingly ineffective, regardless of individual pilot skill or courage. The captured aircraft testing program continued operating as long as practically possible, attempting to provide tactical intelligence that might improve German pilot survivability, even as strategic outcomes became inevitable and final defeat approached. German pilots who had flown captured Mustangs extensively and understood Allied aircraft capabilities faced the war's end with complex and mixed emotions. Professional pilots appreciated the engineering achievements represented by aircraft like the P-51, even while regretting their service on the losing side of history's most destructive war. Many harboured no illusions about Germany's defeat being anything other than total and unconditional, having witnessed firsthand the overwhelming material advantages Allied forces possessed in every dimension of military power. The captured Mustang testing program represents a fascinating and instructive chapter in World War II aviation history, illustrating how professional military organizations attempt to understand and counter opponent advantages through systematic intelligence gathering even under desperate circumstances. The program provided tactically valuable knowledge to German pilots through direct experience with captured aircraft, but this knowledge ultimately could not overcome the fundamental imbalances in industrial capacity, resource availability, technological capabilities, and trained personnel that characterized the air war during 1944 and 1945. German forces fought with remarkable courage, impressive tactical skill, and professional competence, but faced opponents with superior resources, better equipment, more thorough training, and an advantageous strategic position that proved decisive. The admission by German test pilots that they had never encountered handling characteristics like those demonstrated by the Mustang represented professional acknowledgement of American engineering achievement and realistic recognition of the significant performance gaps German pilots faced in combat operations. This acknowledgement, forced by direct experience rather than propaganda or second-hand intelligence reports, illustrated how confronting uncomfortable realities sometimes requires direct personal experience that cannot be dismissed or explained away through wishful thinking or ideological assumptions. The legacy of the Wanda Circus Rosarius and similar programs extends beyond their immediate tactical impact to demonstrate the value of systematic intelligence gathering, professional competence in technical evaluation, and honest assessment of enemy capabilities even under the most difficult strategic circumstances.